Here we go, talking about momentum impulse. Okay, so in this problem here, we've got a car. It has a mass of 1,400 kilograms. So our mass is 1,400 kg. And it's traveling in what we're just calling the positive direction. And it takes 10.5 seconds. So we've got a time here. We've got a time of 10.5 seconds. To slow from 25 meters per second. So it looks like an initial velocity is 25 meters per second. To a velocity of 12 meters per second. And we would just like to figure out what is the average force on the car during this time. So try this problem out. Draw yourself a little picture. It might give you an idea of what's going on a little bit more. And then see what you get on this. We're going to pause this video here. You pause this online. And then, when we come back, we'll see what we get. Okay. So we're back. We're taking a look at this answer here. So we know that since we're looking for a force, and we have a time that this force is acting on the car, we can use an impulse, and that impulse is a change in momentum. So we can say once again that F times T equals a mass times a change in velocity, VF minus VI. And luckily for us, in this example, if we kind of drew the car like Grandpappy Botzer, always taught us, we've got a really poorly drawn car here. Initially, it's going vroom, and then out here, it's still poorly drawn, but it's going like vroom. We are slowing down, right? And if we're slowing down, that means some force, whether it's a brake or a rhino that just ran into us, whatever, that force is opposing our motion. And since we called the positive direction is the way we're traveling initially to the right, that means this force is acting in the negative direction there. So let's see what's going down here. We start putting numbers here into our force equation, or our impulse momentum equation. We have F times the time of 10.5 seconds equals the mass of 1,400 multiplied by VF minus VI. So that's going to be, the final velocity is 12. It's positive because we're still going in the positive direction, minus the initial velocity of 25. And at this point, we need to break this down and solve it. We know that 12 minus 25 should give us negative 13. Let's just double check that. It is true. So we've got 1,400 multiplied by negative 13 here. And that's going to equal F times 10.5. And then if we take the 1,400 and negative 13 and multiply those together, so negative 13 times 1,400 is equal to, oh, this is big, so let's come down here. We're going to have F times 10.5 equals negative, which is a good thing, 18,200. And then our last move here would just be to divide by the 10.5. Fwink, fwink. And 18,200 divided by 10.5. That gives us a final force acting on our car to be negative 1,733.3 blah, 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 blah newtons. And this is great because we do and see we have a negative, just like we predicted in our picture. We're opposing the positive motion. It is a large number, and that's totally fine. But when we work out the math, that is what we find as our final answer. So with that, this problem is finished. Hopefully you got that answer. If you didn't, hopefully it was just a little math mistake you may have made. And we're going to be doing more practice problems of this coming up in future videos. But for right now, adios, and take it easy.